Good day to you all students. Nudrat Samson here. I welcome you all in physics class. Today we will start chapter number 2, measurements. Topic physical quantities. In physics, today we will study about quantities. Quantities means a considerable amount or number of something in normal life. Example of quantities is how many bananas are in a bunch. Now first of all we will revise what is physics, the branch of science which deals with the study of matter, energy and its interaction between them is called physics. In physics, the quantities are divided into two: physical quantities, non-physical quantities. Now first we will clear our concept about physical and non-physical quantities and then we will proceed forward. Physical quantities. Those quantities which can be measured are called physical quantities. For example, we can measure length. Yes, we can measure mass. The time can also be measured, acceleration, momentum and etc. Non-physical quantities. Those quantities which cannot be measured are called non-physical quantities. For example, like, wish, sorrow, hate, etc. Now the physical quantities. What were physical quantities? Those quantities which can be measured are termed as physical quantities. So in physics, those physical quantities are further divided into two: fundamental and derived quantities. Physical quantities are divided into fundamental and derived quantities. Now we will see what are fundamental quantities and what are derived quantities. Fundamental quantities. Those physical quantities which are independent on its own and do not depend upon other quantities for the measurement. For example, length, mass, time, etc. Derived quantities. Those quantities which are dependent on fundamental quantities are termed as derived quantities. Here we have an example of speed. Speed is derived from the combination of two fundamental quantities, distance and time. Therefore, speed is a derived quantity. Now you here see a table. This table consists of 7 quantities. These 7 quantities are termed as physical fundamental quantities. These are 7 fundamental quantities. First we have here is length. The symbol we use in physics for length is small l. The second physical quantity or the fundamental quantity given over here is mass. We use symbol m. Time t. Electric current I. Thermodynamic temperature T. Amount of substance N. Luminous intensity I, and at the base we have V over here. Now coming to the second type of physical quantities, these are derived quantities. In derived quantities we have displacement. We use symbol for displacement D. For area, capital A. Volume V. Speed, small s. Velocity V. Acceleration, small a. Force, capital F. Energy, capital E. Density P. Momentum, moment, capital T. Power P. Work W. Momentum P. Pressure P. For these fundamental quantities, we use standard unit of measurements. We use standard unit of measurements. Now first we will talk about the term measurement here. Why is it important? A measurement is action of measuring something or some amount of stuff. So it is important to measure certain things, right? Distance, time and accuracy are all great things to be measured. By measuring these things, or in other words, by taking these measurements, we can better understand the world around us. Now coming to the standard units. What do we mean by standard units? A standard unit is a standard measure that remains the same whenever, wherever or by whoever it is used. A very common question rises in our mind. Why do we need a standard unit for measurement? Standard unit of measurement provides a reference point by which objects of weight, length or capacity can be described. Standard units are the units used all over the world for measuring a particular quantity. The need of a standard unit arises when we deal with people when from other places. What are SI units? For the fundamental quantities, SI units have been set. SI is a system international. SI is a system international. SI based units are the standard unit sets for the fundamental quantities. SI system have 7 basic units from which other derived units have been derived. Yes, we have discussed about these fundamental quantities in the previous slide. Now here, as we have discussed before, for the length we have used symbol L. So in an SI system, the unit given to length is meter, and for that we use an abbreviation M. To mass, SI unit given is kilogram, abbreviation is kg. For time, we use a unit seconds, abbreviation S. For electric current, unit given by SI system is ampere. A. Thermodynamic temperature, Kelvin. K. Amount of substance, mole, MOL. Luminous intensity, candela, and the abbreviation is CD. Yes, now here comes the derived quantities. We have discussed this table before. For displacement, we use symbol D and area A. Now, here another table we have here. These are the SI units given by the System International to the derived units. These all are the derived units. As we have discussed before, the derived quantities are those quantities which depend upon physical quantities, or their units are derived from the physical quantities units. For displacement, here we have an SI unit, meter, symbol N. For area, we have meter squared, meter square, meter cube, symbol is M cube, meter per second, and it is written as meter per second. For velocity, we have meter per second, symbol is M/S, and we read as meter per second. Then for acceleration, we have a SI unit, meter per second square. For force we have Newton. Capital N is equals to kilogram meter per second square. Energy we have an SI unit joule. J is equals to Newton meter. Kilogram per meter cubed. Kilogram kg symbol per meter cube. Newton meter. Newton meter. For power we use as a unit watt. What is watt? W is equals to Newton meter per second. For work we use as a unit joule. Joule is equals to Newton meter. Momentum kilogram meter per second. For pressure we use an SI unit, that is Pascal. PA is equals to Newton per meter square. Okay students, now after discussing fundamental units and derived units, let's see some differences between fundamental units and derived units. Fundamental units are all those units which are independent of any other unit, including themselves. Derived units are all those units which are obtained by multiplying or by dividing one or more fundamental units with or without introducing any other numerical factor. Fundamental units cannot be further reduced to elementary level. Yeah, in fact, these are elementary units. Derived units can be reduced to its elementary level, which are composed of fundamental units. Fundamental units cannot be expressed in terms of derived units. Derived units can be expressed in terms of fundamental units. Only 7 fundamental units exist in matrix system or SI system. There exists a large number of derived units in matrix system. 7 fundamental units. Yes, you have seen in the table meter, kilogram, second, Kelvin, mole, ampere, and the 7th one is candela. Few derived units are Newton, joule, watt, volt, Pascal, Celsius, etc. Okay students, now we will discuss the 7 fundamental quantities one by one and their unit. The first one is length. The standard unit for length, width, distance, thickness in matrix system is the meter. Other units of length we use are millimeter, centimeter, decimeter, meter, kilometer. 1 millimeter is equivalent to 0.001 meter. 1 centimeter is equal to 0.01 meter. 1 decimeter is equal to 0.1 meter. 1 meter is equivalent to 1 meter. Obviously 1 kilogram has 1000 meters in it. The second physical quantity we have is mass. Mass is a measure of the amount of matter in an object. The basic unit of mass in matrix system is gram. The kilogram is used for large objects and gram is used for small objects such as a dim. Very small objects are measured with the milligram, such as a stamp. 1 kilogram contains 1000 grams in it and 1 gram contains 1000 milligrams in it. 1000 kilograms have 1 metric ton. Next physical quantity we have is time. Standard unit we use for time is second and the symbol we use S. The second is the duration of 9,129,631,770 periods of the radiation corresponding to the transmission between the two hyperfine levels of the ground state of cesium atom. 1 minute contains 60 seconds. 1 hour contains 3600 seconds. 1 microsecond contains 0.001 second. 1 μ second contains 0.00001 seconds and 1 nanosecond contains 0.000000001 seconds. The next physical quantity we have electric current. The standard unit of electric current is ampere. 1 ampere is the electric current flowing in 2 long parallel wires and have the distance of 1 meter in vacuum space, and its given force exactly 2 into 10 raised to power 3 Newton. Next physical quantity we have temperature. Standard unit Kelvin and symbol K is used. The Kelvin, unit of thermodynamic temperature, in the fraction 1/273.16 of the thermodynamic temperature of the triple point of water. The Kelvin is based on absolute zero, the lowest temperature possible. This is 0 Kelvin, which is approximately -273 Celsius or -460 in Fahrenheit. Next physical quantity we have amount of substance. Standard unit we use mole and the symbol is MOL. The mole is the amount of substance of a system that contains exactly 6.0 21418 into 10 raised to power 23 specified elementary entities, which may be atom, molecules, ions, electrons, other particles, or specified groups of such particles. The next fundamental quantity and the last one we have over here is a luminous intensity, the brightness of a light source measured in terms of candela. Candela is defined as the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 raised to power 12 Hertz and that has a radiant intensity in that direction of 1/683 watts per steradian. I hope you have all understood physical quantities and their fundamental and derived quantities and the units which we have used in our daily life. Now students, coming to your home assignment, you have to define physical quantities. Define fundamental and derived quantities. Define fundamental and derived units. Differentiate between fundamental and derived quantities. You have to do your assignment on the Foldscape sheet and submit it on Schoolsgate between 9 to 11 on Saturday. Stay home, be safe, wear mask, protect yourself and follow SOPs for COVID-19 given by WHO, World Health Organization and Government of Pakistan. See you in the next class. Thank you for being with us. Bye-bye.